Hello everyone, welcome to Infinite Loop and another session on data structures and algorithms. So in our previous session, we have seen the ways to find out the time complexity, right? Like we have used a basic tabulation method to find out time complexity for each and every code snippet. It was our part 1 video, guys. So in this session, we will do a part 2 video of the same thing. We will use some hard examples and we'll try to find out the time complexities for them. Okay, so without any delay, let's get started. Firstly, I have a code snippet here. You can clearly see this code snippet has a function which takes two variables as input. And you can see there are two for loops again, where the I is running from 1 to n and j is running from 1 to p. And you have something called as p, which is a power function, right? P is nothing but I power k, right? Here clearly it's given power of I comma k. That means your p, whatever is there here, this is nothing but I power k, right? So instead of p, you just try to make it as I power k. Now let's try to find out the time complexity using the basic tabulation method that we have discussed in our previous video. Like there are two loops, right? That's why I'm taking I, j, and total iterations, right? So firstly, you can clearly see I is starting from 1. So I'm writing here 1. And you can see j is starting from 1. That means I can keep a square bracket and 1. And j ends at p. That means I can write something like this, right? It clearly ends at p. That means it includes p as well. That's why I kept here square bracket as well, right? So can we write here p? No. Why? Because p is nothing but what? It is I power k. So instead of p, we'll try to replace it with I power k, right? That means it's not I power k, it is 1 power k, because for this iteration the I value is what? 1. So that's why we will mention it as 1 power k. So it is as simple as that. Again for I value 2, you can clearly see I is been incremented. It is nothing like division or multiplication. You can clearly see it's just an increment operation. And when I becomes 2, again your j will run from 1 to 2 power k. Why? Because here now I value is 2. Again for third, it will run from 1 to 3 power k. So it is as simple as that. It goes on like this. And you can clearly see here I will end up at n clearly. So I'm writing here n. And what will be your j? It will be from 1 to n power k. For any I value, it will be I power k. So for I equal to n value, it will be n power k. Now the idea is to find out the total iterations. This will actually bring out you the actual time complexity, right? So here you can clearly see there is what? There is a square bracket. That means if there is something like this, a comma b, then the formula is what? B minus a plus 1, right? This is the formula that we have discussed in our previous session. If you haven't watched that, please do have a watch. You can know why we have used this formula. So here, instead of 1 comma 1 power k, we are writing something like 1 power k minus 1 plus 1. That means it will come out to be 1 power k. So here we will write 1 power k. Similarly for this, it will be 2 power k minus 1 plus 1. So again 2 power k. Here 3 power k minus 1 plus 1, 3 power k. So it goes on like this, right? Here it will be what? N power k. So now you got your equation, guys. Now what is the next step that we are going to apply? Simple. We need to find out the summation of all the totals. So we know the method. In the previous session we have discussed, right? We need to find out the summation of all these things. So your answer will be something like 1 power k plus 2 power k plus 3 power k, so on n power k. Now, to find out the time complexity, you need to know that k value, right? So let's try to take for different cases, like for k equal to 1, what is the thing, and for k equal to 2, what is the thing, right? Based on this, we'll try to derive our, equation. If I keep k equal to 1, then what it will become? Here I'm keeping 1. So it will become 1 plus 2 plus so on up to n. So it is as simple as that, sum of n natural numbers. The formula is n into n plus 1 divided by 2. So here you can write n square by 2 plus n by 2. So your time complexity was what? N square by 2, because we are neglecting the lower order term. We are neglecting this. Similarly, for k equal to 2, what is the thing? 1 square plus 2 square plus 3 square, so on, plus n square. So what is the formula for this thing? It is n into n plus 1 into 2n plus 1 divided by 6. This is a basic formula, guys. You know mathematics, right? So in mathematics, for sum of squares, this is the formula. So instead of taking this n square and n term, I'm directly taking the n cube term, because n cube is my highest power. So that will basically represent my time complexity, right? So if I multiply this n with this n and this with this thing, it will become what? N into 2n. That means 2n cube divided by 6. Remaining will be some n square and n terms and some constants. I am neglecting those remaining things, just like I have done here. I have neglected this. So what will it become? It will become n cube divided by 3. So you can clearly see for k equal to 1, your answer is what? N square by 2. And for k equal to 2, what is your answer? N cube by 3. So you can clearly see that for any k value, for any k, for any k value, if I take for any k value, then the answer is what? The answer is n power k plus 1 divided by k plus 1. You know why I'm writing k plus 1? Because for k equal to 1, it is n square by 2. That means one value more than k. That's why I'm writing n power k plus 1. And for k equal to 2 as well, you can clearly see I'm writing n cube by 3. That means more than 2. 1 more than 2. So that's why the idea is what? The final equation that we got is n power k plus 1 divided by k plus 1. That's it. From these all summations, by taking two different k values, we have found out that what is the actual thing for this entire equation. So this is your time complexity. That's it. We got out, right? So your time complexity is what? Big O of n power k plus 1 divided by k plus 1. Now you might be getting one doubt. Why are we representing k? In our previous session, we have seen we have represented time complexity only in terms of n. But why are we writing here k? Because you can clearly see that there are two terms here. One is n, one is k. That means there are two inputs. So this function is completely dependent on these two inputs. That's why I am representing my time complexity in terms of both n as well as k. Okay, hope you got it right. So this is the time complexity. Same thing we have did, guys. Like we have simply took the I value, j value, and we are finding the total. This total will basically bring you the time complexity. Coming to the next question. So you can see again the same thing, right? You have a for loop for I and you have for loop for j. So I'm writing the same thing, I, j, and total. So let's try to quickly find out it, guys. You can clearly see I is starting from n and j is starting from 0 till I. But you can clearly see j is less than I. That means j is not equal to I, but it will be less than I. So it will start from 0 and it will end at I. It will end at I, but it is not equal to I. That's why I'm writing parenthesis. But you can see I values n here. So I can write something like this. N parenthesis. That's it. It's easy, right? Similarly, what happens to I value? You can clearly see I is divided by 2. That means I will become n by 2 for the next iteration. Again, you will get 0 to n by 2. Right? Again, what will happen to our I value? N divided by 4. So again, 0 to n by 4. So it goes on something like this. And you can clearly see I value is something like n by 2 power 0, n by 2 power 1, and this is 2 square, right? So it is something like n by 2 power k. And what is your j? J will be simple, 0 to I. That means n by 2 power k. Right? So it is as simple as that. Now find out what could be your total iterations. Now you can see in the previous session we have discussed for a comma b, which is something like this. What is the formula? It's simple, b minus a. We will don't do any plus 1 or minus 1 because you can clearly see one of them as parenthesis. So here what will be your total? It will be n, because n minus 0 we are doing b minus a. Again n by 2 minus 0, it becomes n by 2. Again n by 4 minus 0, n by 4. So it goes on like this. It will become n by 2 power k. Now the idea is what? Find out the summation of all these things, which will bring out you the actual time complexity. Now let's try to do the same thing that we have done previously, right? N plus n by 2 plus n by 4 plus and so on plus n by 2 power k. Now if I take this n value common, it becomes 1 plus 1 by 2 plus 1 by 4 plus so on 1 by 2 power k. So now from this you could have clearly seen that what is this? This is something in geometric progression, right? And we know in geometric progression, guys, for any terms, like if you take for geometric progression, what it will be? It will be something like a into 1 minus r power something kth term plus 1 divided by 1 minus r. If I take geometric progression, which is something like a plus a by 2, a by 4, something like this, okay? So let me try to erase this part. So you can clearly see I will apply the same formula here. Here my a is first term, and what is r? R is the ratio, that means 1 by 2. So 1 into 1 minus 1 by 2 power k plus 1 divided by 1 minus r. R is nothing but 1 by 2, right? So that is a simple thing. From this what you will get? N into 1 minus 1 power k plus 1 is 1 itself, because 1 power anything is 1, and here 2 power k plus 1. 2 power k plus 1 divided by 1 minus 1 by 2 is 1 by 2 itself, right? So this 2 comes up, 2n into 2 power k plus 1 minus 1 divided by 2 power k plus 1. So this is the final thing, right? Now if I try to reduce it something like this, 2n into 2 power k plus 1 minus 1 divided by, so now this 2 power k plus 1, I'll try to write something like 2 power k into 2, right? So it comes out to be 2 power k plus 1 only, right? So here this 2 and 2 will get cancelled, and you can clearly see what is our final equation. N into 2 power k plus 1 divided by 2 power k minus n by 2 power k. Nothing, guys, I've just multiplied with each and every term, right? I've tried to multiply this with n into 2 power k plus 1 divided by 2 power k, and again n into 1 divided by 2 power k, okay? So now you could have observed in our question, you can clearly see I is greater than 0, right? That means there is a possibility that I can be equal to 1, right? Definitely I is every time the I is going by dividing with 2, right? But there is absolutely a chance that I will definitely become equal to 1, right? So if I is equal to 1, I can write something like this: n by 2 power k equal to 1. Is it true? Because I is nothing but what? You can clearly see I here. I is nothing but something which is in the terms of n by 2 power k. This k value will change every time, but I is something that is n by 2 power k. So from this you could have got right, n by 2 power k is nothing but what? N by 2 power k is 1. So if my n by 2 power k is 1, if it is 1, then what can I do here? This is simply what? This is simply 1. And also here also I have one more n by 2 power k, right? Let me try to reduce this as well. N into 2 power k into 2 power 1 divided by 2 power k minus n by 2 power k, right? I've tried to reduce this LHS part, okay, I mean this left side part. So from this what we can write? Can you guess? This 2 power k, 2 power k gets cancelled. 2 into n, it becomes 2n minus. Now I'm writing this n by 2 power k as 1. That's it. We got out our time complexity. That means we got out an equation which is in terms of n and constants, right? So 2n minus 1 is your actual thing. Nothing we have did, guys. We have tried to reduce this 2 power k plus 1 into 2 power k into 2, and we are making it something like this. So 2n minus 1 is your answer. That means what is your time complexity? Simple. Big O of n, right? 2n in the sense we need to neglect that constant, right? So big O of n is the time complexity. Again we have done the same strategy. We have took I value, we have took j, and we are simplifying the total, and total will bring out you the actual time complexity. It will actually bring you an equation. From that equation you can derive your complexity. Coming to the next question, guys, you can clearly see here there is a first for loop which is running from n by 2 till n, and there is a second for loop starting from 2 to n. You can observe some basic thing here. Your j is running from 2 to n, and j every time it's getting multiplied by 2. That means if you keep a special focus on this second for loop, it is clearly independent of this first for loop. In the previous two questions, we have seen that j is dependent on this I value, right? and j here it's dependent on p, that means power function. Power function is an I power k, right? That's why j is also dependent on I in this question. In this question also same, but here you can see j is something like an individual loop that is running, right? And you could have already guessed the time complexity for this if you have seen my previous sessions. Here every time j is getting multiplied by 2, that means j is going something like 2, 4, 8 and going till 2 power k. So you got 2 power k, that means simple, the complexity is log n base 2. That's it. Here this is a constant thing, right? That's why for this second for loop it is log n base 2. And the simple thing left is what? The first for loop. First for loop is starting from n by 2, and every time you can see this n by 2 is getting incremented by 1. So this loop is running from n by 2 till n, right? This is an actual thing for this first for loop, and every time you can see n by 2 is getting what? Incremented by 1, something like this, and it goes until what? N. So what is the complexity for this? It is as simple as that, linear complexity, right? Every time you can see it's doing some, it's not dividing by 2, but the same thing is happening, but you can see it's something like 1 2 something like this, right? So clearly the complexity for this outer for loop is n. Hope you got it. So the entire complexity is what? N into log n base 2. That's it. We have took this as two individual loops, I mean two loops, and we have tried to find out the time complexity. So you can clearly see in these type of questions there is no requirement of tabulation, because you can clearly see the second for loop is independent of this I value, right? And you can also see you have got out the second loop complexity, which is becoming in terms of 2 per k. That's why I wrote it as log n base 2, which we have seen in the previous video. And for I equal to n by 2, and this question for this part you can clearly see n by 2 is the same thing that's happening, right? The only thing that is changing is 1 2 3, and it's going till n. It's going till n. So it is simple, starting from n going to l, going till n. That means the complexity is n, right? So the entire complexity for this question is what? We go of n into log n base 2, right? So without going in deep about that question, let's try to do another question. So hope you got the idea about the previous question, guys. So if you have any doubts, please post it in comment. Coming to this question, you can clearly see again in this question, I is starting from 0 to n, and you can see j is, there is some while loop here. Instead of a simple for loop, you can see a while loop here. J less than n and array of I is less than or equal to array of j, right? So actually this is a special question, guys. You just try to find out the tabulation method here. You might end up with getting nothing, because you can clearly see there is a special condition that is, it is checking every time, right? Of course j is less than n, this is a simple thing, but there is nothing like in the previous two questions. You can clearly see it's starting from 0, and j you can see it has started with 0, right? So it starts with 0 and j is less than n, that means something like this, and I gets again incremented, and j will again start with what? You can see j plus plus, and you can clearly say there is some, misconception kind of thing in this question, because this question is not like typical things that we have solved in the previous tabulation method, right? Now you don't know what is the j value here actually. For to write this new thing, you can clearly see j value will get incremented. It depends on this condition, whatever condition it's checking, depends on these both conditions. So here you just, can't do this tabulation method to find out the time complexity. So what we need to do now, the simple thing that we can do is doing it manually, right? Let us take an array, guys. Let's take an array which contains something like 4 2 4 2 18 6 5. Let's, I have took a random array, okay? And from this I'm mentioning the indexes, and you can clearly see j is started from 0, that means j is initially here, and I is also starting from 0, so I is initially here. And you can see when I is 0, it enters into the next while loop, and j less than n, that means 0 less than n, yes. And you are checking array of I less than or equal to array of j, that means array of I and array of j both are at same positions, right? So 4 less than or equal to 4, yes, equal. So your j will get incremented. Now your j comes here, and you can clearly see what, again j less than n, and you can see array of I, that means your I is here, right? So I'm writing something like this, your array of I and your j is somewhere here now. array of I is 4, array of j is 2. 4 less than or equal to 2. Is this true? No. So here your loop comes out, because here there's an AND operation and both must be true, right? So it comes out and your I will get again incremented, right? So now your I comes here, and you can see again j less than n and array of I less than or equal to array of j. Yes, true. Again j will get incremented, and you can clearly see that again j is less than n and array of I less than array of j. 2 less than 18, yes, true. So again j will get incremented, and again 2 less than 6, yes, again j will get incremented, and you can see 2 less than 5, again your j comes out of this array. J came out of the array. Okay, now what happens if j comes out of the array? Again your I you know again you will come out of this and your I gets incremented. I will come here somewhere, and again you will check j less than n. It doesn't satisfy. Again your I gets incremented. Again j less than n, because j, you can clearly see it has came out of the array. Array size is 5, right? But your j is something like 6, because your j has come out of it, right? So after, I think j is 5, right? 0 1 2 3 4 and 5, right? So both are equal, but you're checking j less than n, so that's why your I again gets incremented. So you can clearly see after some time I will also come out of this loop. So you can clearly see here, guys, I is being visited for entire array and j is also visited the entire array. That means I is visiting the entire array which is of size n. J is also visiting the entire array which is of size n. That means this entire code snippet, whatever code snippet is there, it is something running for 2n times. You take whichever may be the array. At some point j comes out of the array and at some point I comes out of the array. That means I is visiting for n times and your j is also visiting for n times only. It's not n into n, remember, right? For every I value j is visiting the entire array. No, it's not like that. I is at some particular location and your j is going somewhere, right? J has already moved to some location when I is at some other location, right? So it is not n into n, it is actually n plus n. So from this you got out 2n, your complexity will be big of n. So it is as simple as that. Hope you got it why we are not telling it as n into n, because you can clearly see at some position j went somewhere here, right? And you can see I was still here. So that's why I'm telling j is not visiting every time j is not visiting the entire array, right? So that is the idea for it. That's why I've kept here 2n and your complexity will be big of n. So that is about this question, guys. That's it for this session, and I would like to give you this as your homework. You try to guess out the complexity, and it's a simple match the following question. Okay, match the following. You try to match this everything with the correct following, and try to keep it in the comment, guys. I want each and everyone to keep the following things in the comment. Okay, so that's it about this video. Please try to like, share and subscribe to my channel if you like my content. uh, that's it, guys. Thank you.